Himanshu, there you might mute.
Okay, so start karte hain. Today we are going to cover functions, and in functions we are starting with what functions are, how to define functions, what are arguments, what are local variables, how to pass arguments, how to take values from functions, which is basically a return value, uh, introduction to top-down programming, functions and arrays, and recursion. So today's session is going to be about an hour long, and we are going to keep it very simple. Of course, as for the feedback from the last two sessions, feedbacks are good, but the thing is, some people said things are covered in a very easy and simple manner. The thing is, things are easy and things are very simple. To get the idea of things, it is very easy to understand what a function is, to understand what an array is, and any other things. What requires is practice. So you might have an idea about what functions are, or let's say after today's session, you understand what functions are, how functions work, but you might struggle with writing a function because that thing takes practice. So understanding something and having a command over it are two different things. The purpose of this session series is to create a basic understanding, a fundamental understanding of concepts, because after that we are going to cover many things. We saw when we covered sessions about rootkit development, exploit development, people were struggling a lot. They were not able to understand the programs. They were not able to understand few details. And that is why it is imperative to understand how programming works as well as how C programs work. But if you are expecting to become a very good programmer in just about 2-3 sessions, 1 hour each, without even attempting one or two programs by yourself, then that is not going to happen. Okay, so starting with functions. So a function, what is a function? A function is basically a piece of code which has a name. A basically named piece of code is a function which can be reused again and again multiple times. So let's see how we can start with functions. Stop saving. Okay, so for this exercise, the purpose is to calculate power of a function of a number. For example, of a number, which is, if you have ever used a function uh, by the name POW or in most cases that is POW. In Java that is math.pow. You don't need to import math. In C that is again you need to include math.h. But again, just a second. So we can do two things. One thing is, first let's write a simple program which takes int number and int bar. Now this is in this piece of code we are just going to write the code without function. So let's just take input. Int exp for the exponent, and base is for the number. So let's just fix it. Base goes here, printf and exponent for this. And then power is going to be calculated as base raised to power exponent. But how do we do this? So there are two things that we can do. One approach is we can use loops. So let's just take the loop alternative for now. When we will discuss recursion, we will also see how to do this via recursion, right? So for I less than exp, and I just have r equals to 1. R equals to so we need to multiply the number again and again unless exponent becomes 0. So unless exponent is greater than 0, and next. You did not miss anything. We are just starting with functions, what functions are. So initially we are writing a program which will calculate power of a number without functions, and then we will write a function to do the same thing. So that's just okay. To calculate a power, let's just say to calculate power is, let's suppose 2 raised to 2 is equals to 2 into 2, and 2 raised to power 3 would be 2 into 2 into 2. So basically we have to keep multiplying it again and again. So what would the loop will be? I 0 and I minus equals to power into base. Let's see if this works. Percent d raised to percent d equals to percent d. Base raised to exponent gives power. And let's see if it works. GCC function. And of course, it was going to get segmentation fault.
So you forgot to add ampersand sign.
Yeah.
Ampersand sign in scanf.
Yes, I forgot that thing. No fault. Compile it again. 8, it works fine. 2, 4, 16, 2, 5, 32. Okay, it works fine. 3, 3, 27. Great. So this is the code. But what happens is, now let's suppose you have to make it generic because you just cannot use it this way in most of the applications, right? Even if you are creating a calculator, which is one of the most simple thing that is taught in schools, colleges, or whatever, this code is not portable. This code is not reusable. This code is not, you just cannot integrate it in any other program, even if you are using that thing. So this is the problem that comes when you are designing large software or big softwares. This is perfectly fine if your program just does this thing, right? Until and unless your program only calculates power, you would not want to write this code, because there will be code above this, there will be code below this, and let's suppose you need to calculate power multiple times, right? Let's suppose you need to calculate power 3 times or 4 times, or how many times the user wants, but there are other functionality as well, so you cannot even keep it in an infinite loop. Now for that thing, what you have to do is you have to write a, instead, that what would be the better way is to just put it in a function and call the function whenever user wants to I would say calculate the power. That way it would be much easier. For example, let's just take this and calculate a function, write a function. So the syntax for the function is function syntax is return type, function name, parameters, and of course let's just write it properly, type parameter, type parameter, and however or how many you want to do that. And this is how it works. In the braces there would be the function body, and corresponding to the return type you will return a value which would be of return type which you mentioned here, right? So let's create a function int, and the function name would be power. So int base, int exponent. Okay, so let's just compile it again, and unfortunately there is a little problem. Oh yeah, it expects uh, two parameters and then it returns something. So instead of that, let's just do it this way, void. So void means no return, and let's not take any parameters for now. So void again. This is compiled. Function 2, 3. Okay, so now we have accomplished something. Now what this gives us, you might ask, what is the advantage of this thing? Now the advantage of this thing is you can call this function anytime you want. For example, let's suppose there were 500 lines here with multiple functionality. Then you call the function, then again same whatever, then you call the function again. Also you can save this function as a part of a different file. You can save it in a different header file, and you can then supply that different header file to as a part of your program, so that when your programmer, for example, someone else on your team is working on that thing, you just pass the header file and there we go. You just need to call the function. The functionality is already there. Now this is one advantage, but this function requires a bit of
Huh?
So now the problem with this function is it is not kind of usable in any case because it does not take any parameter. So considering a proper power function, you might expect to pass it some parameters because I mean, at the end of the day, if you say that it is taking the parameters, let's suppose you do not want that thing, or let's suppose you, if you want a different message to appear, or if you want different variables or different way of taking input, you can have that in your custom code, right? You can think of this as a, you can think of this if you think this function, the structure of this function as something, for example, the standard header files that are provided to you, right? So that would give you additional, that would give the developer additional flexibility to write the code however they want. So this is one. Let's just copy this, create a new file, and then you will understand what I'm talking about. Font2.c. Now let's rewrite this thing. Instead, let's just take this as the parameters, and base and exponent, and let's just have this result return. So now what this function does is it returns a value of type integer. It takes two parameters. One is base, second is exponent, and it calculates base raised to power exponent and returns that number. So what we can do is, so this is how it would look like. Result equals to let's compile this to see function 2, 2, 3. Okay, there's a little problem. Okay, int base, int exponent, I is equals to power into base. This should be fine. Oh yeah, power is the address. So I need to use result 238. So now see this. This function does what it is supposed to do. It calculates power. There is no additional code. There is no additional message that this function is printing on the screen. Now compare this with this function. So this has additional code because the function is supposed to be one thing in of itself. And I mean, I'm not saying you cannot take inputs in functions, but this code is far better than this code. Why? Because all the handling of user input as well as the formatting for the printing on screen and whatever, it is left on the main function. And now this function can be even used as an API. You can just export this function, and other programs can just import this function by using hash include if you're talking about C or any other language, right? So all that they have to do is the power function calculates power based on, you pass it a base and an exponent, and it just returns you the power. So however you present all those data, however you take the input, it all depends on you. Now let's suppose you need to calculate it twice, but then now what we are doing is base plus 1 and exponent plus 1. And let's just do this. Control C. Now, in this case, what we are doing is we are adding 1 to the base and adding 1 to the exponent and calculating it again. So, so 2 raised to power 2 is 4 and 3 cube is 2 square is 2, 3 cube is 27. So this is the portability part where you just need to call the function with its parameters, which are expected parameters, and you get the result. So this is how you define functions and how you use functions. Another thing to do note is you have to define the function or define the symbol before you use it. For example, you cannot do this because when the compiler comes to main for compilation, it sees power, but there has been no function by the name power or anything else before main. So the compiler will throw an error. Let me show you this. Implicit declaration of function power. So to fix that thing, what you have to do is we define the functions before main so that every function has been seen by the compiler by the time it reaches there, and once it reaches there, it will see that this function a function has already been uh, defined, and therefore it will link to that function. So I hope this is all easy and you understand these things, right? Any questions? Okay, I don't think there are any questions. So to understand the function, the I would say to understand the using or usage of functions or the requirement of functions, let's understand what a top-down programming is, what top-down programming model is, and how you use functions in top-down programming. So let's just create another file, and it won't take much. So what we're going to do is, purpose of this file would be to create a calculator-like function. And for this, we are going to, initially we are just going to use main, and once we have done, we have seen how main works, we will we will create the code or write the code in a much better way. For example, without any thinking part or whatever, right? So what a calculator needs a menu, and we are adding functionality only: add, subtract, multiply, divide, and remainder. Let's say modulo, right? A very basic calculator. So let's just say int num1 for the number 1, num2 for the number 2, result, rest for the result, and let's run it in an infinite loop. Printf welcome to calculator calc.exe. Int choice Just a second. Okay, so I will explain this thing. These are the parameters to main, as we saw in this function that in this example, that this is the return type, as explained here. This is after return type. This is the function name. So this is the function name. Therefore, this is the function name. This is the return type of main. And when we return 0, so 0 is returned as an integer. So this is return 0 as integer is being returned. Now this thing, there are two parameters to main, and it is one of the variations of main. What you can do, for example, you can call main as this, main as void, which is basically pretty much the same thing in C. Then you can call it main, for example, int argc char argv. So uh, what this signifies is if you type main as this variation, you can read runtime arguments. For example, this will take this tells you how many runtime arguments are presented to main when this program is called or executed, and this points to the runtime arguments. So we will see them. We will have a look at them when we use those things. For now, let's just keep it as a standard. Okay, cool. Now the third thing is main int argc, which is, as I told, number of runtime arguments passed to main, array of runtime values or arguments, and then there's another array of character pointers, which is environment pointer. So what are the environment values that this program should have at runtime? And since we do not require this thing, we do not need to pass the environment pointer. So what happens is, if we use the second one instead of the third one, it inherits the environment values from its parent, which is bash or z shell in this case, right? So it really depends, and until unless we are not using those things, it really does not matter. I use this one because in most of the cases I keep my programs uh, in a way so that they take runtime arguments instead of user interaction based programs. But yeah, fine. So now let's enter your choice. Scanf %d. Now we can use if else to compare whether 1 was entered, 2 was entered, 3 was entered, 4 or 5 or something else. But since there are other possibilities, and we discussed in the first session that when equality is compared, best thing is switch case. So switch on choice, and there we go. Now case 1. So case 1 would be the case for addition, and therefore we can take the two numbers here, or we can just take the numbers again and again and put, for example, printf first, enter first number. But I'll tell you why this is a problem if we take the input right here, right? The problem is in case a user enters 6 or something other than something which is not displayed in the menu. So that would be stupid to take numbers just because you do not even have that choice in the first place. So you need to first have a look at the choice. Now, number 1, the second number, scanf %d, since these things are something which are not supposed to be here, so we are going to do these things as this, and this is case 1. So this formatting takes a bit of time, but once we do this, it would be easier for us to do it next time. Okay, and in this case, you calculate result as num1 plus num2, and then you break out of this switch case because the program has processed if else. Now, same goes for case 2, and let's just copy all of this. All we need to do is to just replace the plus with the minus, right? Then case 3 would again do the same thing, just multiply, and case 4 would divide. Moving on to case 5, okay, this will return the remainder. And now in case of default, we are having default case, which is basically any other value besides these 5. So printf error, right? And since after default, it by default gets out of the switch statement, so let's just print the result. Printf result is %t and result. Now this is one thing. You can see how big this program is, and it is not really very good in case of looking. This program does not -ocalc.exe. Let's type 3, 1, 2. Answer is 2. And because of the loop that we used here, this statement while 1, which is basically while true, and therefore this is an infinite loop. It will keep repeating itself again and again, and therefore until and unless we kill it with Control C, it will keep running. 2 and 3, the result would be 5. Now let's just quit. Okay, great. So this is a simple program. Now this program can be improved in many ways, because this is first thing, this is not readable. We can make this program very readable, or much readable, very simply, because by using functions. So let's copy this and create a calc2, calc3.c. Okay, fine. So first thing we are going to do is so we are going to put this as a menu, right? So Control-X and menu void, so that it does not take any parameters. And let's just do this, print int choice, and once it has been done, return choice, right? Now we can implement checking of choice. In this case, for example, if choice is greater than 5 or choice is less than 1, let's just print wrong choice and return 0. So okay, choice equals to 0. Simply. Now what we are signifying here is if choice is 0, in case of this case, the program will exit simply. So okay, great. Choice equals to menu and default again. Okay, fine. So we do not need this thing. So we reduce this thing as a single line. Now we have this. Second thing we can do is we can write all the functions. For example, int add, int num1, int num2. So instead of doing this again and again, what we can do is we can cut this thing and we can say if choice as okay, I need to implement that thing again, greater than 5 or choice is less than 0. So what this comparison checks is if the entered value is greater than 5 or the value is less than 0, which is basically any default, any other value which does not fall into our choices, we just print uh, wrong value, wrong choice, and just exit. And for that, since we are inside a loop, so we use the break statement, and there we get out of the loop. Now, since we have done that thing, we have made sure that if we have a valid choice, we need two numbers, and choice 1 result equals to add num1 num2. Same goes for this. We need to delete this and return num1 plus num2 simply. And same will go for other functions. Subtract num1 minus num2, multiply, divide, int mod. Sorry, we already have this copied. So this is and this is our program. All we need to do is this. Case2 would be subtract. So instead of this part, we can remove this. Now we can subtract, multiply, divide, modulo. And we don't really need a default case. So there we go. Now, if you see in this case, let's just compile it. UCC calculator 3.exe to calc. Okay, so this is this. So let's try an invalid choice. So we get a wrong choice. Great. Now let's say add. First number is 1, second number is 2, result is 3. Again, welcome to calculator. So what this offers is, okay, fine. Yeah. So what this offers is, uh, now if you compare this program and this program, see, size would be pretty much, its size is 90 lines and its size is 90 lines, pretty much the same. The difference here is, if you see the functionality, for example, let's say you start from this, okay, so these lines are just a menu, nothing more, but you see these lines have been repeated again and again. So the input taking functionality has been repeated again and again in every single case. And besides that, what we have is, if we can classify these as functions, you really have to read whole code, whole case code to understand what is going on here. Now comparing this to this, let's say here, right, start with main. We have a menu function called menu function. So let's see what menu function does. Okay, so this just prints a menu, nothing more. Great. Now moving down, it returns an integer, as we already saw. It returns a choice, wrong or right. If it is wrong, great. Then we take input for once, right? So we take input once, and then, now if you see case one, if you don't even see what is up there and you just see case one, case two, you can see, okay, add function is called, there is a function which is called add, and it takes two parameters, number one and number two. Subtract, you see the homogeneity in this case. Result is equal to the value of the function, and the function takes two parameters, and the names tell you what the function does in most cases, right? And that is one of the guidelines how to write function names. The function name should be descriptive, and the function name should tell you what the function does, or what the function should be performing, so that when you are understanding or when you are reading the code, you get an idea what the function is doing, right? So let's suppose this function was AAA. So I would have to go to see what AAA function is doing. For example, in this case, it is number one and number two. But if this is multiply, so I get the idea what multiply is doing. Another thing is, as we talked in previous exercise or example, this code is neither portable, neither I would say usable, and not even manageable, right? There's so much clutter in this code. And when you start programming, usually new programmers tend to do this thing. For example, put everything in the case one, put everything in case two, case three, and those things. Here you can see it is pretty much managed. And in any case, uh, let's talk about any other one other thing. And that thing is, let's suppose you want to increase the functionality of add. For example, you need to increase the functionality of division. Let's suppose you want to add uh, the case of division by zero. So let's add the division by zero, or test for division by zero. So if num2 is equals to 0, then what you have to do is printf cannot divide by 0, and since you cannot divide by 0, you have to set the result equal to 0 or -1 or whatever you want to say, and you have to break out of this switch, because if you do not break it here, it will go there, or else you can put this in an else statement. For example, if you don't want to break here, you can just do an else. Let's just adjust it so that it looks good. And now you see, another problem that I'm talking about is, let's suppose you need to increase or add more code to this. Let's suppose you need to, there is a function, or this functionality needs 100 lines of code more, so you need to add 100 more lines here. However, if you do this, for example, in division, right? So let's compare num2 to equal to 0. So printf cannot divide by 0 and return 0. Simple. So this does the same thing. What I'm trying to say is, even if you add 100 lines or 2000 lines of code in this particular function, it will not affect the readability of your program, right? Your main function is going to stay the same, and you can make these functions more robust by adding more code, which will not clutter this thing. And therefore functions are said to be named pieces of code, because these can be, first thing is these can be reused again, and second thing is functions are something, if you use properly, they provide, or they make your code more readable, more manageable. So is that clear? Okay, great. So this was for the functions part and top-down programming. Now, this was an example for top-down programming because we had a calculator, which was one thing. Calculator is one thing, and it has its functionality. So we divided the functionality as individual modules. For example, one part is addition, which is actually different from subtraction, because subtraction and addition are two fundamental different functionalities of calculator. So from one, so calculator is the top thing, right? So this is calculator, and we had add, we had subtract, we had multiply, we had divide, and we had then modulo, right? So when you divide the functions or the functionality in such a way that you can create different functions, or you can create different solutions for a particular functionality, then that is what we call top-down programming, right? We start from top, we break down the programs or the problem statement in various subproblems, so that these subproblems can be solved individually. Now we cannot go beyond this in this program, because you cannot break this add into any subproblems, right? You can just simply add two numbers and it is sufficient for the uh, problem solution. Therefore it is where it gets, right? Now moving to last topic for our, okay, so we have two topics remaining: function and arrays, and recursion. So arrays are passed the same way as uh, any other parameters passed. So let's create a function. Okay, Fibonacci series, right? So purpose is to calculate Fibonacci series till nth term, right? For example, if we ask the program what is the fifth term of the Fibonacci series, the program should output it. Now let's, this is the main, and then since Fibonacci series, if you are not familiar with it, it starts with 0 and 1 as the first two elements, and then each element or each uh, number or member element or whatever you want to say is equals to previous element plus second previous element. So this is how it goes. So that means the third element would be 1, fourth would be 2, then 3, then 5, then 8, and you get the point, right? So this is how it goes. So the thing is, if you remember the first session, to choose carefully data types, the first thing is it is 0 and it never goes to negative term. So our function will return the nth term. So unsigned long, let's use unsigned long as, right? and since the term is never going to be -1, so unsigned int nth term. Now this way what we are going to do is term 1 is 0, term 2 is 1, and for int I is, let's just say unsigned it I is uh, so this is going to be a bit complex. So first thing is there, second thing is, and third term is, let's just write that int term 3. Term 3 is term 1 plus term 2. Term 2 is term 3 because those things get again, and term 1 is term 2. Now to calculate third term, so I think we need to start with 2 and nth. I believe this is how it will go. So let's validate I less than 10, and let's start with 1, 3. Return term 3. Okay, so I think we are having a little problem. Unsigned long here, and the same thing is going to be here. Unsigned long here, and return term 3. Good. So unsigned long term. Printf percent dth percent d term equals to percent unsigned long okay. And now for this term, call the function Fibonacci with I. And let's see how it goes, right? So I'm pretty sure it will crash, but let's see. Okay, it works fine. So 0, 1, 1, 2, 3, 5, 8, it works fine. But it is printing third term, fourth term, fifth term. Okay, so this part is right. If I say I need first 20 terms, then it prints first 20 terms. And the problem is this one, the calculation part. 3 goes there, it returns. Third term is 3 goes there, I is less than, I is 2, term 3 is, okay, so there is a little problem in this case. But anyways, it is calculating the terms pretty properly, right? So what we can do is, let's suppose you need to call this function again and again, or you need to store these values inside an array. So you can pass it an array, but we are not going to cover array today because passing the array to function requires understanding of pointers, and we are going to cover pointers in upcoming sessions. So we are skipping that part for now. Moving on to the last session, last topic, that is recursion. So recursion is So recursion is something when a function calls itself, right? So it is basically like you call a function, your function, and inside the function body, you're calling function again. So it looks confusing because it should not make sense, right? How can a function call itself? Now, the point is a function can call itself because it is just a code, and of course, when you call a function, the execution transfers to the code of the function. So yeah, that way you can call a function. But what you have to remember is you need to pass a different argument which was passed initially in the first place. So let's suppose 5 was passed. So if you pass 5 again, so it will call it again, and then it will call it again, which will basically become an infinite loop. So that would totally negate the point of recursion, right? So for this recursion, there are two conditions. Uh, One is, I think only the, only the required condition is it should have a exit condition, which should be reachable, which should be reachable. And what I mean by that is, as I said, if you call function with the argument 5 and this calls the function with argument 5, it will get into an infinite loop. So you must have a method which will see whether to exit from the function or not, right? So exit if the value is something, right? If the value is 1, so you need to exit it. That way, you will not get into an infinite loop, but you, of course, you cannot just pass the same argument. So you have to pass a different argument every single time. So on the surface, that looks like that. So for the exercise, what we're going to do is, in the first exercise, we wrote this function, and now this function is using loop to calculate power, and we are going to use recursion to calculate power again. So power function will call itself again and again. So let's just create a new file, and we need to rewrite this thing. Now power is equal to 1. So uh, if exponent equals to 1, I would say return power, right? And here what we are going to do is we are going to calculate power. uh, yeah. So we need to call the function power again and again. So okay, this is a problem, right? So this is our function which calculates that. So the exit condition would be that exponent becomes equals to 1. So if exponent equals to 1, return current power. So current power is initially 1. Let's just set it to base, right? So return power with base and exponent minus minus. So this is going to be problematic. We need to see how we can write it in a recursive manner. Okay, so instead of this, let's set this to 0, and if it is 0, so we are going to return 1, basically getting rid of the loop. Now if exponent is greater than 0, which is else if exponent is greater than 0, we return base into power of the function uh, exponent minus minus, right? Or else we return, yeah, okay, so let's just not add any other case, right? So let's just set this way and see if this works fine or not, right? So yeah, this is a direct power minus, so 2 and 2, and we get into a segmentation fault. And the reason being, we might have stuck into a loop. So if it was 1, okay, so we need to see something clear. Let's just put it in this, right? And unfortunately we are getting segmentation fault, so we need to see, let's say printf exp is %d and exp. Oh yeah, so we are getting into this loop because we are doing it. So we should get this thing now. Great. So 2 raised to power 3 is 8, and 3 raised to power 4 is 81. Now this is how recursion works, and this now is the time to explain this thing. So what are we doing here? Now tracing the execution. So let's trace the execution. So initially we get the input as 2 and 2. So what happens is base is 2 and base multiplied by, since exponent is not 0 because in the first iteration it is 2, so we skip the if part, we move to else part. So 2 into, so it is return. So this function initially will return 2 into power of 2 and 1. Now what this will do is, let's write it again, 2 into, now this power of 2 into 1 will be written as, again, uh, now considering this situation, exponent is 1 and base is 2. Now in this case exponent is not 0, so we again move to else part. So let's write it, return base is 2 into exponent is power 2 and 0, right? Now again let's write this function call as this way. So this time exponent is 0, right? So exponent is 0 this time, and therefore if exponent is 0 it will return 1. So this function call will look like this, return 2 into, return 2 into, now writing this power as inside this parenthesis, it will return 1, right? So now we are inside the third call. Now third call has been resolved, it has returned 1. So what happens is we're going to return 2, we move to, since this function call has been returned, now we are inside upper function or the function which called it, right? So return 2 into, and this will return 2 because 2 into 1 is 2, and therefore it would go to return 2 into 2, which will return finally 4. And this 4 will then pass to here as the result. And 2 raised to power 2 is 4. Now this is evident from here because see initially, okay, so I said 2 into 3. Okay, I think I need to write it again. Let's just see it again with 2 and 2 as the inputs. So exponent was initially 2 when the first call was made. So this is exponent 2 for the first case, right? So this is first power 2 and 2. This is exponent 2. Then we see the power is, the exponent is not 0, so it will call this way, right? So it will call power with exponent minus 1. And when this function calls, initially it prints exponent as value, right? So 2 minus 1 is 1, and we see exponent as 1. It repeats again, exponent as 0, and once exponent reaches 0, it returns 1. So we again start from we again start coming back from this way. So this returns 1, and then it will multiply 2 into 1, it will return 2, and then it will return 2 into 2, 4. Finally value returned is 4. In case of 3 and 3, it just goes on to one more step because the power is a little more than that. So 3, 2, 1, 0, and then it returns 27. So is that clear? Okay, great. Any questions? Because we have covered pretty much everything for today. Arrays and parameters to function as arrays, that will be covered with pointers because that requires understanding of pointers. So in the session of pointers, we are going to cover that thing, right? Okay, great.
Hi everyone. Hello. Am I audible to everyone? I guess
हाँ
yes.
बिल्कुल आवाज आ रही भाई.
तो कैसा चल रहा तुम लोगों का सेशन?
हो गया हमारा सेशन, कोई क्वेश्चंस नहीं, कोई प्रॉब्लम नहीं अब तक. ग्रेट, मस्त चल रहा भाई.
अच्छा. So how's the session? Anyone? Any updates like you're liking the session or not? If you don't like it, we can kick Himanshu out.
हाँ बिल्कुल.
Oh, they want you. हाय इतना प्यार. बताओ लड़कों को तुमसे प्यार हो गया?
बिल्कुल भाई बिल्कुल.
चलो हमें भी प्यार दे दिया करो.
तो भी पढ़ा लो.
Okay, so पढ़ाना से याद है, we're starting web application as well. So once Himanshu finishing up, you got 2 sessions to select between. So C++ will be going on weekdays and web application will be going on weekends. And red teaming will be on Sunday or Saturday. Not sure about the timing. Okay, so we're trying to get you everything. Now it's up to you guys. Like we need participants. Having 7 or 10 people, that's not a good thing, right? So in YouTube, we are getting hits like 20, 30 people, but in Zoom, we're not getting anyone. So let's try to engage people here as much as possible. Okay, because YouTube going to be on 720 and we have to upload 1080p version later on. So that will be a thing. Okay, so